Welcome to qnawire.
So we're going to say that we're going to set up three velocities. This would be the plane, or rather we'll say P, A, and then A, E, and we'll define them right now. This is going to be, this one here, the plane, the velocity of the plane relative to the Earth. This would be the plane relative to the air, and this would be the air relative to the Earth, where this is going to simply be the wind velocity. So in the problem, we are going to say a coordinate system, plus y is north, plus x is east. It really doesn't matter what you choose your plus and y to be, as long as you define it in the beginning. You can choose your own reference, but here we're going to say conventionally plus y is north, plus x is east. So we can first say that the plane, the velocity of the plane relative to the air, this is given. And this is going to be equal to negative 220 kilometers per hour. And this is due west, so that's why it's negative. And this would be in the x direction, of course. And we can say that this would be plus 0 kilometers per hour. This would be j hat. So velocity of the plane to the air has no y component. So we can then say that after 0.50 hours, we can find the velocity of the plane relative to the Earth. So now we can say that here, the velocity of the plane relative to the Earth in the x direction would be equal to negative 120 kilometers divided by 0.500 hours. This is giving us negative 240 kilometers per hour. This is, of course, west. And then the velocity of the plane relative to the Earth in the y direction, this would be essentially negative 20 kilometers divided by 0.500 hours. This is giving us negative 40 kilometers per hour directed towards the south. So asking us for the wind velocity for part A, we can safely say that essentially for part A, the velocity of the air relative to the Earth, so the wind velocity, would be equal to the velocity of the plane relative to the Earth minus the velocity of the plane relative to the air. And so this is simply going to be equal to, we can say, negative 20 kilometers per hour I hat. And that would simply be, again, negative 220. Negative 240 minus 220 minus negative 220. So it would be negative 240 plus 220, negative 20 kilometers per hour. And then here in the y, it would be plus, we can say plus negative 40 kilometers per hour, because initially there's 0 minus 40 minus, so the velocity of the air relative to the Earth minus 40 kilometers j hat. And this would be our wind velocity. This would be our final answer for part A here. Now, for part B, it's asking us, my apologies, we're not done with part A, in the sense that we found it in unit vector form. We need to find the magnitude and the direction. So for part A, the magnitude of the air relative to the Earth, of the velocity vector of the air relative to the Earth, this would be the square root of negative 20 kilometers per hour quantity squared plus negative 40 kilometers per hour quantity squared. This is giving us 44.7 kilometers per hour. This would be the final answer for part A in the terms of the magnitude. Now for the direction, we can say theta would be arctan of the y component, negative 40, divided by the x component, negative 20. And so this would be tan of 1/2. This is giving us 63.4 degrees. And we have an x component, a negative component. So here, this is in the third quadrant. So this would be below the negative x-axis. This would be our full direction for the wind velocity for part A. Now, for B, they're asking wind velocity is 40 kilometers due south. In what direction should the pilot set her course to travel due west? So we say that then, for part B, we could first say that, again, the rule for combining the relative velocities would still be the velocity of the plane relative to the Earth. This would be equal to the velocity of the plane relative to the air plus the velocity of the air relative to the Earth. And so we can then say that the velocity of the plane relative to the air, this is 220 kilometers per hour. We don't know the direction yet. And the velocity of the air relative to the Earth has a 40 kilometers per hour, but this is due south. So these vectors have different values than in part A. And so the direction of the velocity of the plane relative to the Earth is due west, but we don't know its magnitude. So we can then say that here we can create a little diagram. Actually, let's go down first. So this is not to scale, but it will help us evaluate. And so this right here would be the velocity of the air relative to the Earth due south. Due west would be the velocity of the plane relative to the air. And then the velocity of the plane relative to the Earth, the velocity of the plane relative to the air would be at an angle. We're going to choose that this angle right here is phi, and by the alternate interior angle theorem, this would also be phi as well. So we can then simply find the direction, and we can say that sine of phi would be equal to the velocity of the air relative to the Earth divided by the velocity of the plane relative to the air. And this is going to be equal to 40 kilometers divided by 40 kilometers per hour divided by 220 kilometers per hour. This is giving us 0.1818, and then phi would simply be arc sine of 0.1818, and we're finding that phi, the direction, would be 10.5 degrees, and so the pilot should set her course 10.5 degrees, we can say above the negative x-axis. And this would be 10.5 degrees if you wanted to, north and south and those Cartesian directions, we can say 10.5 degrees north of west. Either answer is correct. So 10.5 degrees above the negative x-axis, or again, 10.5 degrees north of west. That is the end of the solution. Thank you for watching.